Hello viewers, welcome once again to the eMath learning platform by Peter Ekaja. My YouTube channel is still eMath learning platform and the email address is ekajapeter@gmail.com. Below are also the contacts in case of any clarification or question from you. Now today we are going to look at solving simultaneous equations using the matrix method. What do we mean by this? Now, we have basically three steps we have to follow in order to solve a system of simultaneous equations. And for this case, we shall start with a system with only two variables. Step number one, write the equations in matrix form. What do we mean by this? You're going to be given a system of simultaneous equations with two variables. So what you do, this matrix form we are talking about is obtained by simply writing down the coefficients of your variables in a matrix form, as we shall see later in the examples. Step number two, find the adjoint of the 2 by 2 matrix. And step number three, pre-multiply both sides of the matrix equation by the adjoint matrix. Let's look at how this is done. Examples. Number one, solve the simultaneous equations. 2x minus 3y equals to 7, x plus 4y equals to negative 2. What do we do in this case? Now, something very important. Let's look at these two simultaneous equations first. I realize in the first equation, the coefficient of x is 2, coefficient of y is negative 3. In the second equation, the coefficient of x is 1 and the coefficient of y is 4. So 2, negative 3, 1, 4 will give us our 2 by 2 matrix that we're talking about. So you just extract the 2, goes with 1 in the first column, negative 3 goes with 4 in the next column. And so you will come up with a 2 by 2 matrix. Let's look at that illustration. So our solution. So this is what we have just been talking about. 2 was the coefficient of x in the first equation, and 1 was the coefficient of x in the second equation. Negative 3 was the coefficient of y in the first equation, and 4 was the coefficient of y in the second equation. So you again multiply by another 2 by 1 matrix, which has x, y, your variables that you're looking for. Then the 7, negative 2 is simply what we had on our right hand side here. So we had 7 and negative 2. So you also form a 2 by 1 matrix on the right hand side with the 7 and the negative 2, as you can see here. Let's look at the next step. Simply let any letter of your choice. For me, I chose to use A to be this matrix of yours that you formed from the coefficients of the variables. Next step to that, find its adjoint. How do you find the adjoint? Exchange the elements in the major diagonal and change the signs of the elements in the minor diagonal. So I've exchanged 4 and 2, but I've changed these signs. This has become a negative, but this has become a positive. That is how I got the adjoint. Next to that, you pre-multiply by this adjoint. You multiply this original expression. You multiply this whole equation by your adjoint matrix. But when you're multiplying, the order matters a lot. So you begin with your adjoint matrix on the left-hand side. And the same thing applies to the right-hand side. You still begin with your adjoint matrix. So the next step is now going to be multiplying this matrix and this matrix. Then multiplying this matrix and this matrix. How do we simply multiply these two matrices? Look at this. I am simply going to go by a row by column. So it is going to be this row which contains 4, 3, multiplied by this column which contains 2 and 1. So I'm going to say 4 times 2 will give me 8. Then I say plus 3 times 1, which will give me 11. So after getting that, even only that information, it can guide you, because once you have 11 here in your first column or first row, then automatically you will have a diagonal. I am having 11 also here, and the other positions will simply be taken by 0. If you try out that, you will actually find out that is true. So once I have 11 here as our first element, automatically this element in this position will also be 11, and these other positions will always be 0. If you can try out, let's check out for this 0 and see whether it is true. We shall say 3. So 4 times negative 3 is negative 12 plus 3 times 4, I get positive 12. So negative 12 plus 12 gives me 0. If you want to try out for this, negative 1 times 2, you get negative 2 plus 2 times 1, you get positive 2. So negative 2 plus positive 2, you surely get 0. So interesting. So what is the simplest way? Just have the first row together with the first column to guide you. So I will have 4 by 2. I get 8 plus 3 by 1. I get 3. So 3 plus 8 will give me 11. Once I have 11 here, I don't need to ask what to write here. I simply write 11. And the other positions are automatically taken up by 0, 0. That is the simplest way of saving time as a good mathematician. Then for this, we multiply this row by this and also this row by this column. So it's going to be 4 times 7, which is automatically 28, plus 3 times negative 2. And so that will be 28 plus negative 6, and that gives you 22. Multiply this row also by this column. So it will be negative 1 times 7 plus 2 times negative 2, and that will give you negative 11. Next step to this, you're again going to multiply a row by column. So it's going to be 11 by x, then 0 by y. So it is simply 11 times x, giving you 11x. And 11x, remember, corresponds to 22. 0 by x is also 0, then 11 times y is 11y. So it will also correspond to negative 11, as you see in the next step here. Remember, in this case, if you divide through by 11, you simply get 2 as your value of x. Then in this case, 11y equals to negative 11. If you also divide by 11, you will surely get y as negative 1. That is how simple it is to solve simultaneous equations with two variables using the matrix method. We are going to look at example 2. We are going to look at example 2. Say solve the simultaneous equations x minus 2y equals to 12, y plus 3y equals to 1. Now look at this case again. I simply look at the coefficient of x. Now remember, here they try to disorganize the order a bit. So do not be confused to pick the 1 here and you pick the 1 from y. When you're picking the 1 from x, make sure you pick the 3 from the x. And when you're picking the negative 2, make sure you pick it together with 1. So 1, 3 will give us the first column, and negative 2, 1 will give us the next column. It's because they just try to rearrange and disorganize you slightly, but do not allow the disorganization. So our solution, we have 1, 3. 1 is the coefficient of x here, and 3 is the coefficient of x here. Negative 2 is the coefficient of y here, and 1 is the coefficient of y here. Multiply by xy and equate it to what we have on the right hand side. Next, let A to be your matrix. You could use another letter. And after this, get the adjoint. And the adjoint, we say you just simply exchange the elements in the major diagonal. In this case, we have 1, 1, so we are lucky. You realize someone may not realize that you've actually exchanged, but ideally, the concept is you have to exchange. You're only lucky that in this case, the numbers or the elements are the same. Then in this case, we simply change the signs. So this becomes a negative, this becomes a positive. Next step, pre-multiply. Begin with your adjoint matrix. So you're multiplying this original matrix here. But remember, beginning by the adjoint matrix on the left-hand side and beginning by the adjoint matrix on the right-hand side also. Should you change that order, you will surely lose direction. Let's check out how to again multiply these two matrices. Simply, it's going to be 1 times 1, which is 1, plus 2 by 3. 2 by 3 is 6, so 6 plus 1 is 7. Once I know that I have 7 in this position, automatically this will also be 7. Other positions, it is not your business, they will be simply 0, 0. Then multiply by xy is equals to, you multiply this also a row by column, then a row by column, which will give you 3 and negative 23. Next to that, get 7, multiply by x. Of course, 0 by y is 0, so it is just 7 by x equals to 3. I beg your pardon here, there is a simple mistake here that we could correct. So this is supposed to be 3, not 311 as we had seen earlier. Allow me make that adjustment. Then this is going to be 7y equals negative 23, which now can be solved. If we solve these two equations, this will give us 3 out of 7 as the value of x, and when we solve this, it will give us negative 23 out of 7 as the value of y, as you can see here below. So that is basically the concept of solving simultaneous equations using the matrix method. We could move on and look at number 3. So number 3 says solve the simultaneous equations x plus y equals 3, then negative 2y plus 3x plus 1 equals to 0. I am loving this question because of the disorganization or the rearrangement made in the second equation. So please, like I told you, always be very, very, very careful. First, make sure you only have terms containing x and y on the left-hand side. So it means this one has to be moved to the right. And once you move it to the right, it becomes a negative. So it means we are going to now have our coefficient as 1 for x, 1 for y, and 3 for x, then negative 2 for y. But on the right hand side, we shall have 3 and negative 1, as we can see in our solution. So we have 1, 3, 1, negative 2. 1 is from the x, the coefficient of x. The 3 is the coefficient of x in the second equation. 1 is the coefficient of y in the first equation. And negative 2 is from the second equation, the coefficient of y from the second equation. And on the right hand side, we have 3, negative 1. Next step to that, let any letter of your choice be your matrix, which you have formed from the coefficients, and get its adjoint. Adjoint, we are simply exchanging these elements in the major diagonal, and we are changing the signs of the elements in the minor diagonal. That is why you see now we have negative 2 here, 1 here, but this is negative 1, negative 3. The next step is pre-multiplying. This is our adjoint matrix, which has been multiplied by this, and again the same adjoint matrix is multiplied by this. That is how we are getting this and this. Remember, the adjoint matrix starts first. The order has to be followed strictly. It has to be the first matrix, then you follow by what you already had here and also what you already had at this stage. From that simple multiplication again, negative 2 times 1. I'm just going to take the first row and the first column, and that will give me the other results. Negative 2 times 1 will be negative 2, plus negative 1 times 3, I will get negative 5 in total, because this will be negative 2 and this will be negative 3. So once I have negative 5, I will simply put a negative 5 here. The other positions will be taken up by 0, 0. Into xy is equals to. So you multiply this row by this column. So it will be negative 2 by 3, which is negative 6. Then negative 1 times negative 1 is positive 1. Now negative 6 plus 1 should be giving us negative. So this is supposed to be negative 5, not positive 5. The negative 3 by 3 will give us negative 9. Then 1 by negative 1 will give us negative 1. Should you add them, you will surely get negative 10. Next step to this is simply multiply negative 5 by x. That will be negative 5x, but this will be 0 by y. So it means with negative 5x equals negative 5. And also negative 5 will multiply the y to give us negative 10. And when you try to solve those steps, you will surely come up with x as 1 and y as 2. So our solutions to the system of simultaneous equation above is x equals to 1 and y equals to 2. Now, dear viewers, learners out there, after having these 3 examples, I really believe you've got the concept to continue and try out the exercise below. So I'm giving part A up to part H. So you'll try it out and check out. Always try to confirm your answers. Actually, when you want to prove whether you're right, in any simultaneous equation you solve. Try and substitute the values of x and y you've obtained in any of the two equations given to you, and if the left hand side balances the right hand side, then you will be perfectly correct. With that, allow me thank you so much and have the best of your day.